I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture, I'm excited to discuss one of the most critical aspects of the rapidly expanding 5G ecosystem, that is security. As many of you know, 5G is not just an incremental improvement over previous generations of mobile networks, that is 1G, 2G, 3G, 4G, etc. It is a transformational technology that promises faster speeds, reduced latency, and the ability to connect billions of devices simultaneously. This opens up exciting possibilities in areas like autonomous vehicles, smart cities, healthcare, and the Internet of Things, that is IoT. However, with this promise comes new and complex security challenges. We'll see one by one. And first, we'll see the, the introduction to 5G security. The 5G network overview first we'll see. The 5G represents, so before going into the overview, this 5G design allows it to handle more diverse and demanding applications than previous generations. It introduces new architectural features like network slicing, virtualization, edge computing, which increase both flexibility and complexity. However, these advancements also broaden the attack surface and expose potential vulnerabilities that hackers could exploit. Yeah, okay. So we'll see in detail. First, we'll see the 5G network overview. This 5G represents the fifth generation of wireless technology, all you know that, designed to deliver high speed data transfer, ultra low latency, and massive connectivity. This new generation aims to support a wide range of advanced applications such as Internet of Things, smart cities, autonomous vehicles, and remote healthcare. These capabilities will significantly enhance user experiences and enable next generation services across various industries. The expanded capacity and, and capabilities of 5G are expected to revolutionize how we interact with the world, facilitating a more connected and efficient ecosystem. And what are all the security challenges we are facing? The deployment of 5G networks brings significant security challenges due to increased attack surface that results from a higher density of devices and the integration of IoT technologies. With billions of devices connected, from sensors to smart appliances, the complexity of managing their security become daunting. Additionally, 5G's architecture include innovations such as edge computing and network slicing, which introduce new vulnerabilities that can be exploited if not properly secured. Both user devices and the infrastructure supporting the network need robust protection against a wide range of threats, requiring continuous advancement in security protocols and practices. Next, key security risks in 5G. The first one is network slicing. Network slicing in 5G enables the creation of multiple isolated virtual networks on top of the shared physical infrastructure. Each slide, each slice can be customized for specific applications or use cases such as high-speed data, low latency services, or IoT applications. While this offers flexibility and efficiency, it also presents a significant security challenge. If proper isolation protocols are not implemented, there is a risk of interslice attacks where an attacker could exploit weaknesses in one slice to compromise others, potentially leading to data breaches, service disruption, or network manipulation. Next is supply chain risks. The 5G ecosystem is built on a wide variety of hardware and software components sourced from multiple vendors across different regions. This global supply chain increases the potential of introducing malicious elements such as backdoors or vulnerabilities into the system. Supply chain attacks can compromise the integrity of both the network infrastructure and the user devices, making it a significant security concern that need to be addressed through thorough vetting and monitoring of vendors and components. Next, increased attack surface. 5G networks will integrate billions of devices, many of which will be mobile, low power, and potentially insecure. The sheer scale and the diversity of these devices expand the attack surface of the network, offering more entry points for malicious actors. For example, Internet of Things, what do you mean by IoT? Devices are often poorly secured and can be exploited to launch a distributed denial of services, that is DDoS. Attacks are used as entry points for larger network intrusions. TDOS means, I'll tell you, distribution denial of services. The proliferation of connected devices require new approaches to device authentication, secure communication, and monitoring 5G core, that is, and monitoring. Next, 5G core and edge vulnerabilities. The 5G network architecture is highly distributed, that is centralized one, with the 5G core network responsible for managing key features like authentication, signaling, and mobile routing, etc. That is data management, we can call it as. Both the centralized and edge components are involved in this process, making the network vulnerable to attacks targeting data management, signaling, or the authentication process itself. Attackers could exploit weaknesses in the distributed network infrastructure, leading to issues such as unauthorized access, data interception, or service disruption. Next is security measures in 5G networks. In this enhanced encryption, 5G networks employ advanced encryption techniques to protect data in transit, ensuring that communication between devices and network elements is secure. End-to-end encryption, such as 256-bit AES, that is AES encryption, is widely used to prevent unauthorized interception of sensitive data. In addition to encryption, strong authentication mechanism like PKI, public key infrastructure, this we are calling it as PKI, and enhanced SIM cards, eSIM. We can call it as eSIM, ensure that only legitimate devices and users can access the network. This multi-layered approach to encryption and authentication is critical in safeguarding the integrity and confidentiality of communications. Next, network slicing isolation. To mitigate risks associated with the network slicing, 5G networks implement strong isolation protocols between slices. These protocols ensure that traffic within one slice cannot interfere with or access data from other slices. Techniques such as virtual private networks, that we can call it as VPNs, virtual private networks, and traffic segmentation are used to maintain secure boundaries between slices. This isolation prevents cross slice attacks and ensures that critical applications such as healthcare or autonomous vehicles remain unsecure even if other slices are compromised. Next, zero trust architecture. The zero trust security model is an essential component of 5G security. requiring continuous verification of users, devices, and applications before granting access to any network resources. In a zero trust environment, what it will do is trust is never assumed, even if the user or device is inside the network perimeter. This approach helps to prevent unauthorized access, lateral movement, and data exfiltration by ensuring that all entities are continuously validated and authenticated throughout their interactions with the network. Next, security for virtualization and cloud. 5G networks leverage virtualization technologies and cloud native solutions which introduce additional security challenges. Virtualized network functions, that is VNFs, and cloud environments require specified security controls such as Secure Access Service Edge, SASE. SASE means Secure Access Service Edge to ensure data integrity and access control. SASE integrates network security and cloud security into a unified platform, offering enhanced protection for data and services in distributed multi-cloud environment. These cloud-native security solutions are essential for securing 5G's highly virtualized infrastructure. So these are all the security measures in 5G networks: enhanced encryption, network slicing, isolation, zero trust architecture, and security for virtualization and cloud. Next, we'll see the feature security trends in 5G. AI, ML, these are all that is advanced research in this 5G, AI, artificial intelligence, and machine learning for threat reduction. The use of artificial intelligence, that is AI, and machine learning, ML, in 5G security is rapidly gaining traction. These technologies can be used to detect anomalies in real time, predict potential threat, and automate responses to security incidents. AI-driven system can analyze large volumes of data to identify suspicious activities such as unusual traffic patterns or unauthorized access attempts and take action to mitigate risks before they escalate into major security breaches. Next to 5G standards and global cooperation. As 5G networks span across borders, global cooperation between telecom operators, regulatory bodies, and cybersecurity experts is crucial. Standardization efforts led by organizations like 3GPP, that is, Third Generation Partnership Project, and ITU. What do you mean by ITU? The International Telecommunication Union are key to creating a unified security framework, that is 3GPP and ITU. These standards ensure that the security protocols are consistent and interoperable across different regions, reducing vulnerabilities and promoting a secure global 5G ecosystem. Next, the post-quantum cryptography. With the anticipated rise of quantum computing, traditional cryptographic algorithms may become vulnerable to attacks. To future-proof 5G security, to future-proof 5G security, the industry is exploring post-quantum cryptography, that is PQC, post quantum cryptography, to develop new encryption methods resistant to quantum decryption techniques. These new cryptographic algorithms will be essential to maintaining the confidentiality and integrity of data in 5G networks as quantum computers become more powerful. Next, private 5G networks. This is also one of the future security trends in the 5G. The growing adoption of private 5G networks by enterprises is a notable trend in securing sensitive data and applications. Private 5G networks provide organizations with the full control over their network infrastructure and security policies, enabling them to tailor security features to meet their specific needs. This allows businesses to ensure stronger data privacy, customized access controls, and enhanced threat protection, especially in industries like manufacturing, healthcare, and finance, where data security is a top priority. So the feature security trends are AI ML learning for threat reduction, 5G standards and global cooperation, post quantum cryptography, and private 5G networks. Coming into the conclusion, so larger attack surface, the traditional to 5G network introduces a large attack surface due to the increased complexity of the network and massive number of connected devices. As 5G expands to support billions of IoT devices, mobile endpoints and new applications, the potential entry points for cyber attacks multiply. This makes securing the network more challenging as each new device or technology increases the opportunities for malicious actors to exploit vulnerabilities. Therefore, securing this vast ecosystem is crucial to protect against unauthorized access, data breaches, and other threats. Next, advanced security measures. To address the growing security challenges, advanced security measures are built into the 5G architecture. These include robust encryption techniques such as end-to-end point encryption for data in transit, strong authentication mechanism, for example PKI eSIM, and key separation to ensure that different keys are used for different purposes, reducing the risk of the compromise. By employing these measures, 5G network can maintain the confidentiality, integrity, and authenticity of data, which ensuring that only authorized users and devices can access network services. Next, privacy and legal compliances. The privacy protection is a critical concern for 5G networks as the large scale deployment of connected devices and applications raises the potential for sensitive user data to be exposed. 5G systems must safeguard personal information such as user identities and location data from unauthorized access. Additionally, 5G networks must comply with the lawful interception laws, which allow law enforcement agencies to access communication data under certain circumstances. Striking the right balance between ensuring privacy and meeting regulatory requirement is essential for maintaining trust in 5G ecosystem. Next, future security challenges. Looking ahead, 5G will face future security challenges as it becomes an even more integral part of global communications. These challenges include evolving threats such as more sophisticated cyber attacks, the rise of quantum computing that could break current encryption methods, and the need for continuous adaptation to new security risks. To stay ahead of these threats, the 5G security framework will need to undergo constant updates, refinement, and innovation. Ongoing development in areas like post quantum cryptography, AI driven threat detection, and cross industry collaboration will be essential to ensure that 5G networks remain resilient and secure. So, thank you for joining me in this lecture to explore the world of 5G security. I hope this session provided insights into both the exciting possibilities and the critical challenges we face as we work to secure this transformative technology. Together, by anticipating these risks and implementing robust strategies, we can harness the full potential of 5G while safeguarding our networks, devices, and data. Thank you once again.